Hello everyone, my name is Vyom Shah and welcome to our project Deep Dive on DiT4SR, which stands for Diffusion Transformer for Real World Image Super Resolution. So the base paper proposes leveraging a stable diffusion thread architecture to perform the image super resolution. The crucial innovation is that they condition the transformer explicitly on the low resolution image to preserve the fidelity. So our project consists of three main tracks: reproducing the base results, training on a custom dataset, and introducing a novel OCR based prompting method. So let us start with the reproduction. So we merged the multiple datasets like div2k, div8k, and ffhq to create a mixture of over 23,000 samples. Using the DiT4SR training pipeline, we successfully reproduced the base model. So as you can see, the weights and biases dashboard, we trained this model for 150k steps, establishing our baseline for comparison. For the second track, we wanted to test the architecture's data efficiency. So we curated a smaller custom dataset consisting of the ISR dataset, ISR Unsplash, and Unsplashed Light 5K. So these custom datasets were roughly totaling to 14,300 samples, which were much smaller than the reproduction set. Surprisingly, despite having significantly less data, the custom dataset model slightly outperformed the reproduction baseline on the LPIPS metric, scoring 0.3730 compared to the baseline's 0.3789. So this proved the robustness of the DiT4SR architecture even on the compact, high quality data mixtures. Now, on to the core novelty of this project. The OCR aware prompt conditioning. Standard captioning models like Lava are great at describing the scenes but terrible at reading text inside the images. When standard DiT4SR tries to super resolve the text like store signs or documents, the text often comes out garbled. To fix this, we integrated an OCR filtering and prompting pipeline. So we used dots.ocr to dynamically extract the text from images. During training, we appended this text directly to the prompt under the format OCR text is recognized text. We filtered the assay text dataset to only include the samples with positive OCR results, yielding a focused 23.7k sample dataset. Now, look at the real text evaluations results. By introducing OCR aware prompts, the model achieved visible improvements on LPIPS, dropping from 0.3810 to 0.3644, as well as boosts in clip IQA and man IQA scores. This proves the hypothesis: explicit text conditioning dramatically improves the text heavy image restoration.
Let me quickly pull up the code base. This project is highly modularized compared to original upstream repository. Under model DiT4SR, we implemented the transformer modifications. Under utils data, you will find scripts like append OCR to prompts, which interfaces with the local validation server to dynamically create OCR prompts. In bash data and bash, we have created end-to-end shell launch scripts, making it easy to generate the datasets and launching the Hugging Face accelerate mixed precision training. For example, train 1 dB directly hooks into the OCR novelty dataset. To demonstrate this, we have built an interactive Gradio application that strings the whole interface chain together specifically for the OCR novelty. Firstly, I will upload an image from an examples list that contains some text. Watch what happens when I click the Run Lava. The background spins up the lava vision model and generates a base visual caption of the scene. Now as you can see, the base prompt has been generated. Now I'll click on the extract OCR button. The dots OCR model scans the image and extracts the low resolution text. You can see the extracted text which is already which is in the OCR which is in the OCR augmented prompt added as the OCR text which is present. Now uh, finally I check append OCR text and hit the run OCR enhanced DiT4SR. This sends the augmented prompt through the SD3 text encoder into the DiT4SR model along with the low resolution latents. As we can see, the image is already highly resoluted with properly uh, the OCR augmented text. Let's look at this result. Yeah. You can see how heavily degraded the original bicubic upsample text is. Our OCR conditioned DiT4SR completely reconstruct the characters cleanly, accurately adhering to the text that to OCR extended. To wrap up, this project successfully reproduced the DiT4SR framework, proved its data efficiency on a custom dataset, and fundamentally enhanced its capability on text-heavy images through OCR condition prompting. We have open sourced all models and datasets to the Hugging Face Hub under Nisarg's profile. Feel free to explore the code, test, and Gradio demo yourself, and download the pre-trained checkpoints. We can look at the reproduction results from the monument from the real SR, the flowers from the real SR, and the Wukong and face portrait. All these are very highly upscaled. Uh, from the custom dataset training, we we can see the nature from the real SR again and the architecture. All these images are also highly extracted, highly upscaled, and we can see the super resolution. Now the OCR based from the novel improvement, we can see that the texts are perfectly uh, detected and creating a very highly super resolution. We can also see the language changes from the OCR. Thank you for your